Okay, this is for the test review, the scatterplots and regression lines from page 28, number 3. So what we have here is we have a table that shows the data Morgan collected during a 10-mile bike ride that took 50 minutes. And this cumulative distance is measured in miles. So we each want to take this information and make a scatter plot of it on a calculator and then use linear regression. So let's enter in a video here. Okay, this should work here. I'm going to make a video at the right here of my calculator. So to get to the scatter plot, the first thing you do is you go to the Stat button and you push Enter on the edit and you'll get to your lists. Now on your lists here, sometimes you have numbers on your lists. You just go up to the L1 here and you push Clear. And Clear is just below this arrow pad. Do not push Delete. It'll delete your whole L1. So push Clear. Now you have a nice clear list to work with. So I'm going to enter in our points from our list up here. 0, 0, 10, 0, 10.0, 20.0, 30.0, 40.0, and 50.0. Then the L2, push the right arrow key, I'm going to enter in 0.0, 2.3, 4.4, 5.7, 8.2, and 10.0. Now I have those points, I want to make a scatter plot. So to make the scatter plot, I push the second button right here. Actually, let me clear out this decimal accident I put there. I can go second stat plot. Now usually your plot 1 has your L1 and your L2 on there already. So I'm going to push Enter on plot 1. I'm going to turn it on. Now this right here shows I'm going to be using a scatter plot, which is perfect. I want my X's to be from the L1 list and my Y's to be from the L2 list. And mine are going to have these little circles right there that are open. So now to get that plot up, and I want to use zoom stat to create a usable window. That's part of my directions right here. Use zoom stat. I just push zoom and then go down to number 9, which is stat, and push enter. And see, I got my scatter plot now. So now I want to use linear regression. That was A. I want to use linear regression to find the equation of the line of best fit. So to do that, I will push stat, go over to calculate, and go down to 4, which is linear regression. Push enter. Now it's asking me what list I want to use. Now my X's were my L1s, but my Y's were my L2. So I want to change this to L2. And to do L2, I push second and the number 2, and it gives me my L2. I don't just want to type in L2. Go down to calculate, and you can see it gave me my equation to get my line of best fit. So once we have that, now yours might show your correlation coefficients here. I can actually turn that on by going to second 0, go down to D for diagnostic, and I want to turn my diagnostic on. You don't have to do this, but now what happens is when I go to my stat, calc, linear regression again, same exact thing I just did. Make sure it's L1 and L2 up here, which it is. Push calculate. Now it gives me my linear regression. So you can see my fit in my line is pretty darn good because my R value is really close to 1. And that gives me my line of best fit right there. So we can write that here on our presentation. And the answer would be, your equation would be y equals 0.197x plus 0.17. That comes from the B there. All right. So now we also want to take this linear fit. Okay, so we have that linear fit, and we want to use that to estimate the distance. We're looking at C here, actually. Hold on. Okay, we want to use your linear equation from B to estimate the distance Morgan would travel in 70 minutes. So we would take our equation here, but instead of x, that's our minutes, and our y is our distance. So we would substitute in 70 minutes for x to get the distance she would travel. And that would give you about 13.96 miles. And I say about because we definitely rounded these two off right here when we put them in our equation. So I'm going to put an approximation symbol here. That should make sense. And since if you look at our graph, it makes sense that after 70, it'd be about 13.96. And then, to get the time it would take Morgan to travel 25 miles, we went on to take 25, that's our y value, equals 1.197x plus 0.17. Subtract the 0.17 from both sides. That is 24.83 equals 0.197x. Of course, divide both sides by 1.197. So you have x equals 126, about 126 minutes. And again, that should make sense, since if we want to go 25 miles, it'd be 25. We'd have to go down here to 25, and then it would be about 126 minutes. So that answers your question for C. The last thing I would like you to do is to be able to plot, make both the scatter plot on your calculator and the linear regression line on your calculator at the same time. And do this, this shouldn't be too bad. So let's do that. So, got my calculator here, and I've already done the stat plot. So if I go to my graph, I still have my stat plot. All I'm going to do now is on y1, enter my regression line, which is 0.197x plus 0.17. Graph that, and you can see the line of best fit goes pretty well through those points. And that would give you a good idea, or actually it gives you a good idea of how close your line of best fit is. And on the test, you're going to have to show me that, this screen on your calculator.